for my company, and also I have been working on many avionics related projects that were given to me. So that's why I feel that today's workshop will be more detailed than you will find anywhere. So I hope you guys like it. So let's begin. Okay. So uh, is it all right if I begin directly, or there is something else you want to first ask or something?
Abhinav, just 1 minute. If you can
Yes.
just wait for 2 to 3 minutes, because a few more students, they're likely to join the session, and if it is okay for you, if you wait for 4 to 5 minutes more, and then you can start with the presentation.
Sure, sure. It will be all right. I can wait.
Okay. Okay, so my question to everyone, if you guys are excited for today's session, please write yes in the chat. Okay. Okay, seems like that every one of you are interested, really interested. So it would be, it would get more interesting if you guys just turn on your microphones and give a brief introduction to your to and introduce yourself. Can we do that? Anybody?
I guess we have too many introverts in the chat.
So okay, no problem with that. And others, just feel free to just talk about yourself.
It won't be a fun session if you guys don't interact with us. So please do give your feedbacks and everything time to time. So it will be better if you guys start unmute yourself and start answering some things.
Hello, sir.
Hey bro.
I'm Sharad.
Hey Sharad.
I'm an aerospace engineering student from Jain University, Bangalore.
Oh, hey Sharad. It's really nice to meet you. Even I was an aerospace engineer from Jain University as well.
Oh, okay.
Yeah,
I'm
I
so
just
excited to learn about the avionics.
what can you repeat?
I'm so interested to learn about drones.
Yes, it is a really interesting subject. I hope today's session will give you a little bit of insights in that in this subject, and it will pique your not only pique your interest but also so that it also forces you to learn new things. So I'm really hoping that it does what you hope that it should.
Thank you, brother.
Okay, so now I think that we can proceed with the presentation. Avinam, you can start with today's session.
Okay, sure. So, um, so basically, from avionics perspective, this is what I'll be presenting today. First, it will be just a basic introduction to avionics and drones, a little bit of avionics in general as well. Then we'll proceed with more in-depth with more in-depth topics such as avionic components, then in which we'll be discussing flight controllers, GPS, about communication protocols and everything. Then the next thing in the list will be our payloads. So for payloads, I'll get in detail about what type of payload to use for what type of purposes, and then I'll also talk about what are the future trends of uh, drone industry in respect to avionics, like integration of AI and everything. Then I will be sharing my perspective, and then we can have a Q&A session at the last. So, but in between, if there is some doubt that you feel like it's worth sharing, do share it. I'll be happy to answer. So let's begin with the first topic of our presentation: introduction to avionics in drones. Now, introduction in like for us, avionics begins as far as you go with where people actually started with aerospace. So even if you go far back for with the Wright brothers, they used control surfaces to uh, control their flight. What control surfaces were? They were mechanical things, but their brain can be interpreted as the avionics because they were the ones controlling it. So avionics is the combination of electronics and the aviation industry, where electronics are used in aviation industry. We call them avionics. So as I told, avionics work close to mechanics, and the sole purpose of avionics is to control the mechanics. So that's it. But as we are today discussing about drones, in drones there are no control surfaces like ailerons and rudders and elevators like there are in planes. So in drones, the need of avionics become much more prominent because our whole drone movement is controlled by four motors in exact. Those four motors change RPM, they change thrust values time to time just so that it can hover properly and stably. So from next slide I will explain about in more details and what all things are need if you want to build your own drones. You have what all things you need to learn. So okay, let's begin with what all components are there. So the whole components of a drone can be divided in three basic categories. One is data collection, second is flight, that helps with maneuver and everything, and then is functionality. For flights, it's pretty normal with flight controllers because they are the brains. GPS for location, the gyroscope and accelerometer for drone to know where it is, where it's going, and everything. It needs to calibrate that. So for that, and for flight, it's pretty common that we need something to control everything. So that's where radio communication comes in. ESCs are for us to control the motors, and the motors just for the thrust. For let's with functionality, we comes to the payload section. This is the whole payload section where we try to integrate multiple type of cameras, or maybe there are more things that we need. So for now, I've just described about these four things, but there are many more things that can be integrated with a drone. Like for example, you must have seen drone shows and everything. So they are also kind of comes under functionality and payload. So let's go with the first component, flight controllers. So flight controllers are the brain of the drone. They actually use all the income. Yeah, you can actually read everything, but I'm also explaining. So if you want to note something down, there are things on screen that you can note down, but you can always listen to me. So the flight controllers are the brain of the drone. They do all the computing and everything. They collect data from each and every sensor that are present on the drone, and the flight controller itself does the calculations of where it should be, and what it should do to be there. Like for going forward, it will increase the thrust produced by the rear two motors so that it can tilt a bit forward and go ahead. That's how the drone goes ahead. So that's in general how flight controller works. It basically collects every data from each of the components of the drone, and and it calculates its own moves so that we can know where it needs to be. Now, for some examples, like as I told you, you can build your own drones. So for that, some of the examples I have provided are Pixoc series. They are the most basic flight controllers. Also, they are basic, but they are pretty advanced as well. For they have the normal systems and everything you need, so you can connect your own sensors and everything to this to the Pixoc board, and you can use it directly. So basically, this board uh, actually needs a software with it. That software, what we call, is flight controlling software. What in general, most of them use RDPilot. Pilot is an open source platform known for its diverse flight controlling offerings. So CubePilot, Pixoc, and they both are, even Nav.io is from Pilot itself, so that you can actually upload the Pilot software on these autopilots, and they will do all the heavy lifting for you. So the all the code and everything is already written in Pilot, and it is an open source code, so you can modify it according to your own will if you want something different. But for the basic functionality, it has got you completely covered. So let's move on with the next component, with GPS module. GPS module is really important thing for any drone, because the drone, once it gets off in the sky, it does not know what's its altitude, where it is, where it should be. It just knows that these are the coordinates and this is my current position, and that current position can be known only because of the GPS module. Are you guys familiar with how GPS module works? Anyone wants to answer?
Sir, can you repeat your question? I came right now. I had some network issues.
So I was asking, like, do you have any idea of how GPS modules work?
I'm using like there means where the GPS is kept, or you can say time where it is using time difference between two GPS
Yes.
satellites. Or
Yes, you are right. So basically, what GPS module does is, in general, it requires 4 satellites to operate. There are many satellites already on the in the sky. So from those minimum 4 satellites are required. What 3 satellite does is, 3 satellite creates a sphere of influence. Basically, they create a sphere where the module can be. So by triangulating that position, we get our own position. Like you can see in this, from these 3 satellites, it triangulates, okay, where it can be. This creates, okay, this whole place it can be there. It creates the whole zone or area where it can be present. And the third one helps it pinpoint it. The 4 satellites are required for the timing variance, because the time of each satellite is finely tuned. So that's how calculates its own location, so that it needs 1 satellite for time correction. So it just measures basically how long the signal how long the time it takes for signal to reach the GPS module from the satellites. So that's how it works. That's the basic thing. And if you go with more satellites, you get more accuracy. With higher satellite, just working at redundancies to uh, eliminate any position that cannot be true. So in conclusion, GPS modules are really required for drones to, like, they are not exactly required for drones to fly, but they are really required if you want to perform specific tasks with the help of a drone, because drone needs to know where it is to perform any task for you. So let's go with the next topic, gyroscope and accelerometers. So they both are actually used to maintain stability. What gyroscope does is, it tells us the rotational movement of drone each axis. So in X, Y, and Z, if the drone is rotating slightly, it is drifting slightly, it can be calculated and given to us by gyroscopes. And the next is accelerometer. What they does is, they calculate the acceleration in any given axis. So for example, if a drone is flying, if the drone is flying and there is a gust of wind, now the gust of wind will try to knock the drone in one particular direction, or it will try to rotate it. Now, if we don't have gyroscope and accelerometer, our drone just knows, with the help of GPS, it knows where it is. But it won't exactly know if it is shifted just a little bit, or if it's shifting slowly, or if it has turned a little bit, then and it is not facing the direction it should. So that's why gyroscope and accelerometer come, because they help in not only controlling but also stabilizing the drone. So, as I said, the controlling and so precision is the most important thing when flying a drone. Like if you are taking a if you are taking a photo from a drone or anything, and if you are not precise, the whole photo will be jiggly or something, and it won't be how you need it to be. So the whole flying experience will be worst if you are not able to stabilize the drone. So that's where these are required, and not just that, but they also serve for a safety purpose. So I'll go to the next module. Next module is radio communication module. For flying a drone, you can always assign the complete mission to the drone itself, so that it can fly but autonomous, sorry. But if you want to control it from somewhere, you need to have a radio communication. For this, there are many types of radio communication that are already available, that use some use 2.4 gigahertz channel, some use 5 gigahertz channel, some even use 898 channel, 898 megahertz channel. So it all depends on what you want to do, but there are already many radio communication channels that are available, like modules that are available, that have already been paired. So the ground system has already been paired with the air system, so you can directly connect the whole air system inside your drone, and you can actually control it properly. So they also help in stabilize in establishing a two-way connection between the drone and the ground system, because the ground system sometimes need the feedback from the drone as well. Not sometimes, but most of the time it does need the feedback, and also sometimes ground has to change the mission in between while it is in air. So this whole system is controlled by the radio communication, and there are certain protocols such as Mavlink protocol, which I will describe in more detail towards the end. But right now, Mavlink is a kind of protocol that enables this communication via with the help of hardware. So I'll now show you a little bit of detailed connections of how it is usually in a drone, and what a general flight controller looks like. So this controller is called Pixop. Uh, the arrow here, it shows like which side it is facing forward, because they have their own alignments, because they have, as I told, they have their own gyroscopes and accelerometer. Most of the flight controllers comes with their own gyroscope and accelerometer, because they need to be finely tuned. So they come with it, and rest of all the things you can attach to them, so that you can control the drone. So for example, this is a basic diagram of how the flight controller and connections happen. So this is our flight controller. All the motors are first connected to the ESCs that controls the motor. Those that ESCs has three channels in general, but some advanced ESCs have four channels. The three channels are ground, power, and the third channel is PWM, that is called pulse width modulation. This PWM controls the motors by sending ESC certain signals of what it should do. So in that way, it controls the motors in return. So every ESCs can be controlled in, like for the Pixop board, it can be connected to this thing, and then you can use the RD software that I told before to actually properly control each and everything, and tell the board itself that, okay, my main ESC, like my forward motor is connected here, my right forward is connected here, right backward and right left, all are connected. On which ports you can determine it here. Now this needs to be connected to a GPS module, because GPS is an external thing. So the GPS module is connected separately here. This is just the LED panel if you need certain LEDs and everything. So it can be done as well. The battery powers the whole system and is usually connected to the microcontroller. If not, like if microcontroller not our RD pilot, if not connected to the RD pilot, it is separately connected to a certain 1 minute. Yeah, it is separately connected to a separate power supply module that supplies the desired power efficiently to each and every component of the drone. Here is our radio communication channel that I was telling you about, and this is the GPS module. So there are certain things on this where you can actually connect everything for some, because GPS pin can be directly connected, but if you want your drone to have certain different kind of signals passing through it, you can use I2C channel, CAN channel, SPI channel. This type of channels are available in the drone, so that you can, in the autopilot, so that you can use them. Now the next thing will be payloads. Payloads are the main motive that we are creating the drone for. We just, yes, just a flying drone that does all the maneuver looks cool, but at the end of the day there is something that we want out of the drone that can be enabled via payloads. Now each of the payload, as I said before, that there can be many payloads, but for now, general I just described three of them, that are camera system, where it can be just a normal camera system, an HD camera or Sony camera or whatever. Then there is LiDAR cameras. LiDAR cameras are actually useful in mapping a terrain. They do the 3D mapping with the help of LiDAR technology, which is light detection and ranging. So with the help of light, it calculates the distance from the drone and it can create a 3D map of the whole terrain. Now comes the thermal mapping. Thermal mapping is pretty straightforward, because it captures the thermal images, and it can be really useful when you're trying for a search and rescue missions. In search and rescue missions, when you want to find someone, you can actually use thermal imaging cameras, so that the thermal imaging camera can hover over the whole area, and wherever it detects heat signature, it can inspect them closely, and it can transfer that data back to the ground station for the rescue mission. And as I said, for like the camera system, normal cameras, they use this for survey. They capture high quality HD pictures of each system. Then there are certain softwares like Pix4D and many softwares that stitch all those images together to create a big image of the whole area that you are trying to inspect. So these type of payloads are really required. There also exists a multispectral camera, and multispectral camera is useful when you want to capture in more than one spectrum of light. So that in those cases, in specific, like for any specific case or something, this can be really helpful. Now, as I've told you, I've connected all the sensors. I've connected my image taking cameras and everything. So now I need to integrate all of this so that this whole thing works as a single machine. That single machine is, as I told, controlled by none other than our autopilot. And the sensors actually connect each and everything together. So for example, I'll take an example here. If we are like, for example, we are going for a search and rescue mission. Now we just don't want, we can capture the whole image with thermal camera, but we actually want the people to connect to the drone, like, or actually spot the drone, so that they can, if they're hiding somewhere, hiding inside a cave or something, the camera won't go inside a cave all the time. So we need something that can like give them an alert. So at that time, something like a buzzer can come to help. The buzzer and the camera can work together, so that it can not only tell people that okay, it's time to come out, and if you are there, show yourself or something. And the thermal imaging camera will capture the heat signatures of the people, and then inform the ground station that okay, here are some people that needs helping and everything. So now we'll discuss about communication protocols. Like as I told before, communication protocols are one of the most important thing when it comes to drone, because for a drone, it does not only help to to connect the data within the drone itself, but also transfer data efficiently. Because when you are going with wireless technologies, you cannot transfer a huge load of data just like that. You need certain bandwidths. Every data needs to be as compact as it can get, so that it can be transferred as fast as you want. So for that, communication protocols are set up. There are many different communication protocols but for most small UAVs and small drones, the major of it is done via Mavlink. Mavlink is its own communication protocol, and it is used in for small drones because it's a really lightweight. It does not puts up the large amount of data load on the transferring system, and so that it can be transferred as fast as it can. And it's basically a header based protocol. That means every one of the data that you are trying to transfer has its own header and its own value, so that spotting the data gets really easy, because everything is divided into certain blocks of code. So if you just want, for as a ground station, there are many signals that are coming from the drone, but I just want to capture its GPS location and its battery. For GPS location, there is a header called global underscore position underscore int. It tells you your latitude, longitude, altitude, and a lot more things. And it is all stored under whole one header, that is global position in. Same goes for the battery stats. They are also stored under one big chain of code header, that is battery stats. And that battery stats does the whole job related to the battery. So everything of the drone can be divided in certain, so that you can not only the data can be transferred faster, but when you're receiving the data, you can actually look over the data and find it faster, because you just have to search for the header, and whatever the header is representing, it gets really fast, instead of searching the whole data for searching, okay, this is what I want, this is what I want, and you have to go through the whole data. So that's the main thing. Now the next thing is power management, because there is a very strong misbelief that you can just put more batteries and the drone will fly longer, which is not true for most of the time, because as you add more batteries, the weight of the drone increases as well. So for that to work, you need you need to manage you need to manage all the systems really efficiently, so that whatever the power is available on the system, you utilize it properly. Not only that, but if you provide certain equipments with, like for example, GPS module works on 5.5 volts on for a range of 4 volts to 6 volts they work. Now if you provide it with 8 volts, the whole chip will burn and you will be left with nothing, and the whole drone can misbehave, crash, or anything can happen. So in for that, the power management is one of the most required things. So for as someone who if you are trying to design a drone, or if you're trying to make a drone of yourself for yourself, you first need to note down what is the power requirement for each of the equipment that you are using. ESCs offer to go till 24 volts, so even higher ESCs are present. So you can use those ESCs. For GPS model, they are usually to 3.3 volts to 5 volts. For other most of the drone equipments operate at 5 volts, but certain GPS modules operate at 8.4 volts. So certain. So you need to connect each of them perfectly and optimize the battery usage along each of them, so that you get the maximum flight time out of your own drone. Okay, let's go with one of the most important thing, that is safety and redundancy. For safety redundancy, what it means is that redundancy just means that having more of a certain what do we say, a certain sensor, so that you can use it if in case just other one fails. For example, there are orange cubes and everything that are orange cube is just basically another microcontroller that is an RD pilot that you can use inside your own drone. So that has three IMUs. IMUs are nothing but inertial measurement units that combines gyroscopes and accelerometer, and they together works as IMU. So they have three IMUs, two for accuracy and one for redundancy. The last system isn't actually used often unless one of the two fails. So if one of the first two fails, the third system is used. Some drones actually, some drones actually use dual motor systems, in which one motor they are quadcopters basically, but even though they are quadcopters, they have 8 motors in total. And 2 motors are coaxials. So for each motor, they are coaxial, and coaxial just means that they pass through the center of rotation for 2 motors pass on the same axis. So for those drones, the uh, the other motor acts as a redundant motor. They will work, it will be better, but in case another one fails, it can land itself safely instead of just crashing it somewhere. Because honestly, the more you fly drones and everything, anything can go wrong at any time, and you have to be ready for it. So you have to design your whole system just like that, that if certain thing fails, what to do. Like for example, fail safes are certain predefined commands that you set in the systems, that if something were to happen, how should the drone react. This fail safes and everything can be set using the RD pilot software. So I'm just telling you so that once you have all the physical components that I defined before, you can connect all of them together and set these settings for a perfectly flying drone. So as I said, fail-safes are certain predefined action that you keep for using. So for an example, there's battery failsafe. Like if the battery goes beyond, like if the battery's voltage drops beneath 20 volts, for an example, if it's a 24 volt battery, if it drops below 20 volts, that means the battery can fail at any time and it needs to land immediately. So in those points, you can define inside the software itself, and you can tell the flight controller, okay, if the battery percentage goes down below 20 volts, do one thing, land. So what it will do is, as soon as it gets down below 20 volts, it will try to return to the launching site. So that is one thing. And right now, integrating AI with the drones is a little bit of difficult. It's not that it cannot be done, it can be done, but it's difficult because we need the drone avionics to be as lightweight as possible. So certain companies are working on it, and they are trying to make it happen. So in that case, what the AI will help in a way is, like, it can control everything, and it can tell the whole system of how to behave in case of certain fail safes are triggered or something, so that drone can not only achieve the maximum of its potential, but also be safe at the same time. So the next thing I would like to discuss with you guys is the future of avionics in drones, because you guys will be, if you are interested in this topic and you are listening to me, you guys are definitely going to be the future of the drone industry, as it is an avionics session, you are going to be future of avionics as well. So for you to know where you have to put your efforts in is really important. So first of all, the normal challenges will be, for any electronic system, is miniaturizing it, because we want it to be as small and as lightweight as it can be, while without losing its accuracy. We want it to be accurate, and at the same time, we want it to be small. Second thing for any avionics system is power efficiency, because any and every electronic system heats up, because it loses the electrical power via heating. So we want it to power efficient, so that it utilizes as minimal energy that is required, for us to give maximum flight time and everything. Now, the next thing is signal interference. If any of you have might have worked with any drones or any signal related things, you even for phone you might have experienced that certain times when you call someone, the call gets cross connected with other person. So that happens because of signal interference, because too many flying equipments or too many radio channels at a single place can easily cause this interference where two signals get messed up, and each of them gets crisscrossed basically to the other controller, and it can cause a huge scene for everyone. So that is one basic thing that is required. But that's why you might also know, you might not know, or you might know that many of the military zones are no fly zones, because they according to them, their radio equipments are their first priority, so they have declared themselves as a no fly zone, so that any other drone that comes to that fly zone does not interfere with their signal that can be of something really important. So that's why most of the military signals are no fly zone, and they also don't want their privacy to be taken by anyone. So that's another thing. But okay, so another future challenge or whatever you can say, as I told, is integration of AI into the whole systems. So for right now, they use AI for surveillance a little bit, but it all is done on the ground system, not the drone itself. Once you collect all the data from the drone, it gets to your ground system. You take that data and plug it into a system with different softwares, with the help of different softwares, and you can do whatever you want. But for future, if that whole AI system is used inside of the drone itself, it will help a lot for the drone to fly. For example, the most basic thing is uh, obstacle avoidance. For an AI to detect an obstacle, it needs a camera, which we already have them right now. But if we have an AI, it can detect, okay, this is an obstacle, I should avoid it, and not only avoid it, but it will find the shortest route to the whatever position it needs to be. So that's where one thing that AI can help. Another thing that AI can help with is, like, for example, agriculture drones. Now, if you fly agricultural drones, most of the people right now, they use it for delivering pesticides, insecticides, and fertilizers and everything over a large area. But they can also be used for many different things, as for example, monitoring crop health. So it will monitor the crop health, and wherever certain crops are dying down, it can deliver pesticides, because of if because of pests it is dying down, it can deliver pesticides at just those location and not the whole field. And if it needs more manure, it can deliver more manure and everything. So that is one thing that can be integrated with the help of AI. And then another thing is surveillance. Surveillance comes in when you're trying to analyze any system in general. For example, you want to analyze a building or an area. That For a building, we want to analyze, like, what part of the building from exterior needs repairing for a really tall building. Right now, how it works is one drone flies, it captures images of the whole building, then it comes to the ground, and then one human goes through all the images to spot that where the building needs repairing or something. Now, if just imagine if we have four drones flying simultaneously on a building, it will capture the whole area really well, and it will just report back to the ground station what all it thinks needs repairing. So in that way, the flight time of each drone will reduce. The amount of time that you have to fly the drone will reduce, and you can actually do it really well and really efficiently with less time, so it will work out as well. So this is just a quote this is just a quote that any sufficient advanced technology is equivalent to magic. And who would have thought 10 like 15 to 20 years before that we that every person can have their own drones. And if you even go farther back to more than 200 years back, no one would have thought that okay, there will be drones at all, someone flying like bird. It was really fascinating to certain people. So any technology is an equivalent to magic to a certain past generation. For us, some future technologies will be like a will be definitely like magic. So that's all for today. If you have any questions, do let me know. We can connect via LinkedIn. This is my LinkedIn profile. If you have any questions, do let me know. And if you want to connect, we can always connect.
If you guys have any questions, please ask your questions right now.
And if you want me to repeat certain things in more detail, you can also tell that.
Thank you, sir.
Yeah, welcome.
Excuse me, sir.
Yes, tell me.
Yes, sir. I'm Abhinav. I'm from Amrita University Aerospace Department, studying my
Uh,
pre-final year. I have a small query, sir.
yes, yes, yes.
For our Avionics Open Lab project, we were
Yeah.
told to make a drone, in the sense, stabilize a drone in a particular attitude. So we
Okay.
plan to use two sensors and a drone, and to
Yes.
also use an Arduino microcontroller and a gyroscope sensor and a barometric sensor. I mean, the two sensors are this one,
Okay.
gyroscope and barometric sensors.
Got it.
But we have problems regarding the software and the firmware required to make the drone fly and stabilize. We are unable to find that and figure that out.
So for that, I would say you need to also integrate, as I told, accelerometer as well, because it is kind of required for it to stabilize. Because any gust of wind can knock it out, so it needs that to stabilize as well. For that, and then for Arduino, you need to like for example, if you are using any drone, you need to tell it that what certain uh, like maneuvers it needs to do for to counteract those forces. For example, Arduino, it will be a little bit, from my perspective, it will be a little bit slower because it is not that powerful chip that is required. I would say go with STM. There are STM microcontrollers. I would say go with my STM microcontrollers, and they are a bit faster in computing. You can run them at higher clock speeds for you to get a better performance. And then there are also, you can also have a look at the code that is already been built by ArduPilot, as I've referred to them before. You can have a look at their own code at how they stabilize the drone, and you can kind of modify your own code to be more efficient with that type of thing.
Okay, sir. Thank you.
I hope that helped you.
Yes, yes.
You can
Sure.
anyway, you can always connect to me at LinkedIn, and if you have any further doubts, I'll be happy to help.
Thank you, sir. Thank you so much.
Any of you having any other query?
Hi, sir. Can you hear
Hey,
me?
Abhinav.
Hi, sir. Hello.
Yes, tell me.
Sir, thank you for your wonderful presentation. It's very useful for us.
Thank you, thank you. I'm happy you liked it.
Uh, I'd like to share you something about drones. Can I?
Yes, yes, definitely.
Uh, in future, we could see that the drones can carry for medical medicines and can supply foods to um, yeah I came over that in Dubai they were planning to do this is this possible actually?
Definitely, it's possible because there's an already a company named Zipline. If you are not familiar with it, go look them up. They are actually using autonomous UAVs to deliver medicines, even blood to deliver blood to certain people and certain institute that will take more than hours to reach them via land, but they deliver it within 10, 20, 30 minutes at max. So do look them up, and they have created clever drone technologies and clever flight mechanics they have used for creating those drones. So it is definitely possible, and people are using it. So Zipline is based out of Africa, and they use it to deliver medicines in Africa.
Yeah, sir. Thank you.
Yes,
Sir, another one question.
yes.
Sir, how is possible because the drones have made up of less weight and its materials are not if we made with iron or any other which has more value, uh, then it costs more weight. Then how it can lift it?
Are you talking about the what materials that can be used?
Yeah, yeah, yeah.
So many drone manufacturers use aluminium because it's really light, and they actually use alloys of aluminiums. And some even use carbon fiber because carbon fiber can be made really thin and really light. Some certain drone can even just like with all up weight, their all up weight, that is the total weight at takeoff when it's completely accessorized. That is, they have it of around 2 kgs, less than even 2 kgs, and while their actual frame weight is just around 300 200 grams with the help of carbon fiber. So that is, some even use carbon fiber, some use aluminium to design the frame. So those type of materials are possible. They some even use plastic and epoxies. So even that is possible, and even glass fiber. So this type of things are actually possible for us to. They make it possible for us to create lightweight drones.
Power, sir. How much power does it make?
Power, it actually depends on your power. Total power depends on your all of weight and for what time you want to fly it for. Like if you want that the, like, how can I say it? Yeah, if you want your total flight time to be around 2 hours, let's say 120 minutes, so you need to calculate the power consumption of each of the component, and based on that you will determine how much battery is required. Because but you need to also, but the power consumption of motors actually depend on what is the total weight. So there is a sweet spot that you need to do calculations on, and you need to get a sweet spot where the weight of the drone and the power, like the weight of the drone that is already there, plus the battery weight, what amount of power it requires, like what mAh battery, for an example, it requires to fly. So after calculating that, you determine like, okay, what how much battery I need to put inside the drone for it to fly that much amount of time.
Yeah, thank you, sir. Thank you so much.
I hope that I solved your doubts.
Yeah, sir. Yeah.
Is there anyone else that wants?
No, sir.
So I guess that is it for right now. So
Yeah.
I'll just take a quick screenshot of this chat because I want to post it on my LinkedIn. So if anyone wants to turn on their cameras, this will be a good time.
It will be great. So everyone here is requested to turn on the camera so that we can take a selfie.
So I just take the screenshot now. Yeah. So
Yeah. Thank you for turning on your camera.
Thank you, sir.